How do operating systems deal with memory fragmentation? Have you ever wondered how operating systems manage memory so efficiently? One of the key challenges they face is memory fragmentation. This occurs when free memory is split into small, scattered blocks, making it tough to allocate larger areas for processes. Let's break down how operating systems tackle this issue. First, it's important to understand the two main types of fragmentation. Internal fragmentation happens when allocated memory blocks are larger than what is actually needed, leaving unused space inside. On the other hand, external fragmentation occurs when free memory is divided into small pieces, preventing the allocation of larger contiguous blocks, even when there is enough total free memory available. Operating systems use various memory allocation techniques to manage fragmentation. Fixed partition allocation divides memory into fixed-size blocks. While this method is simple, it can lead to internal fragmentation. Dynamic partition allocation, however, allocates variable-sized blocks that closely match the size of the processes, reducing internal fragmentation but possibly increasing external fragmentation. Placement algorithms play a role too. Methods like first fit, best fit, worst fit, and next fit help determine which free memory block to allocate. These methods aim to balance fragmentation with allocation speed. To handle fragmentation effectively, operating systems employ several techniques. Compaction is one such method where the operating system shifts processes in memory to consolidate free space into a larger block. This reduces external fragmentation but requires support for dynamic relocation. Paging is another technique that divides memory into fixed-size pages. This allows for non-contiguous allocation of memory frames, effectively eliminating external fragmentation by using a page table to map virtual memory to physical memory. Segmentation divides memory into logical segments based on program structure, like code and data. While it can face external fragmentation, combining segmentation with paging can help mitigate this issue. Swapping is also used, where processes are temporarily moved between main memory and secondary storage. This frees up memory and helps manage fragmentation. Different operating systems have their own ways of dealing with fragmentation. For instance, Windows and Linux often use paging combined with segmentation or other virtual memory techniques to minimize fragmentation. Real-time operating systems may implement specialized memory management to avoid fragmentation that could cause delays. In practical use, paging is widely adopted in general-purpose operating systems to support multitasking and efficient memory use. Compaction is more common in systems where dynamic relocation is feasible. Embedded or real-time systems might prefer fixed allocation or custom strategies to avoid latency due to fragmentation. Operating systems address memory fragmentation through a mix of allocation strategies and memory management techniques like paging and segmentation. By understanding these methods, we can appreciate how operating systems maintain efficiency and performance in memory management.